Okay, good morning everyone. Today we're looking at Unit 1, Lesson 9, solving multi-step problems using polynomials. So formulas can be used to solve multi-step problems that arise in real-world applications of mathematical modeling, and we'll look at an example of that today. There are many occupations that will use this mathematical modeling to solve problems. So financial analysts, engineers, in the healthcare field. Okay, lots of professions that would use that might require mathematical modeling with polynomial functions. So let's look at an example. Jake has decided to paint his living room. The length of the living room is 9 meters. So we'll just highlight some of the important information. So the length of the living room is 9 meters. The width is 6 meters. And the height from the floor to the ceiling is 3 meters. So if we were going to draw this room, so we're going to draw the room. Something like that, right? It says that the length of the living room is 9 meters, so we'll put 9 meters here. It says the width of the room is 6, and the height is 3. So determine the total surface area that Jake will paint if he uses 2 coats of paint. So we have to think about whatever we calculate here for the walls that we need painted, he's going to paint those walls 2 times. So if we're trying to determine how much is going to get covered in paint, right, we have to determine, well, what formula are we using to model painting these walls? Okay, and that would be represented by the surface area. So we need to calculate the surface area and then look at, well, what are we trying to cover here? We're trying to cover 2 walls that represent the length and the height of the room, and then 2 walls that represent the width and the height of the room, right? These long walls, these 9 by 3 walls, we have 2 of those. So we'll have 2 times 9 by 3. And then the shorter walls, we have 2 of those. Those are 6 by 3 walls. So 2 times 27 plus 2 times 18 will be 54 plus 36. We'll say the surface area is equal to 90 meters squared when we're talking about surface area. But they're going to paint it 2 times, so 2 coats. So really the total surface area of paint we're trying to cover is going to be 180 meters squared. So that's simple enough. We can calculate how much wall area we're trying to cover. But then the real world application starts coming into account with saying, okay, how much paint do we need? How much is this going to cost? What other things should we consider? So let's try answering some of those questions. So how many 4-liter cans of paint should Jake purchase if 1 liter will cover approximately 12 meters squared? Okay, so we know that 1 liter will cover 12 meters squared. So we can set that equal to another ratio, right? We need to figure out how many liters do we need to cover 180 meters squared, right? We could set that up as a proportion. So we could cross multiply. Cross multiply. We've set up this proportional relationship. We should know how to solve. So we're going to have 12 times x on one side is going to equal 180 on the other side. So we'll divide both sides by 12. We should find that x is going to equal 15 liters we're going to need. But remember that we need to figure out how many 4-liter cans we need, because that's how you can purchase the paint, is how many 4-liter cans can we buy. So we're going to take our 15 liters we'll need, and we will divide that by 4, and that'll equal number of cans of paint. Okay, so 15 liters divided by 4, we're going to have 3.75 equals our number of cans. Well, you can't go to the store and say, I'd like 3.75 cans of paint. So we'll say, therefore, Jake will need 4 4-liter cans. Right, we'll have to round up. He'll have to buy 4 and have a little bit left over if necessary. So Jake has found on sale for $30 for each 4-liter can. How much will he spend to paint the room? So if we need 4 cans of it and they're $30 each, we're just going to multiply those together. So 4 times 30 is going to be $120 to paint the room. Okay. A last thing to consider when we're using a real world application is just what are some other factors that nothing mathematical related about it, but what are some factors Sean should consider when he's buying the paint? So he should consider that he might need more than 2 coats, right? Depending on the color, sometimes you might need more than 2 coats just to cover the room. What happens if he has a spill or waste? And then finally, you might want to have some left over. So if the walls get dinged up or if you need to patch a hole in the future, you might need some of that same colored paint to fix any problems on the wall. That's it for your notes today.